Welcome back to the last set of examples for the inner product spaces. And for this one, it's just going to be just regular inner products with just pure linear algebra, no calculus. And so it's going to be four. The fourth one is, I want to say a little long, but it's different. So let's not waste a lot of time and let's jump right into it. So the first one tells us, well, for starters, it asks us to find the inner product space of u and v, the magnitude of u, the magnitude of v, and the distance between u and v for the given inner products. So the first one, we are given that u is equal to 3, 4, v is equal to 5, negative 12, and that their inner product spaces between them is just the dot product. So something that we've done before, something that we've done in the past. So this should be fairly simple. And so our inner product should be just 3 times 5 plus 4 times negative 12. And that will simply be 15 minus 48. I cannot do math, so this would just be 30, 40, 33, I think. No, not 33. Negative 33. Their magnitude is, you already know, the square root of 3 squared plus 4 squared, which is just, this is a triplet, so this would just be 5. And then the magnitude of v, it would be 5 squared plus negative 12 squared, another triplet, which should be 13. And then the distance between them, so u minus v, it is negative 2. What's 12 plus 4? 16. Yes, I think. Let's just assume that it is 16. So the distance between them will simply be negative 2 squared plus 16 squared. And so that'll be the square root of 4 plus 250. Is it 256 or is it 216? I think it's 256. 256. Yeah, because 15 is 225. And so this will just be equal to the square root of 260. Yep. Square root of 260. Cool. That was fast. Well, I mean, it's just a regular dot product. The next one. So now we're given, again, two vectors. And u is negative 4, 3. V is 0, 5. And their product between them is 3u1, v1 plus u2, v2. So our inner product spaces between them will just be what they tell us here. Different color. Wow. Yeah, so this would be 3 times negative 4 times 0. Cool, that just goes to 0. And then 3 times 5, which would just be 15. Our magnitude, well, it's just the magnitude. Oh, I mean, not the magnitude. The square root of the inner product of itself. So this would just be 3 times negative 4 squared plus 3 squared. And so that would just be the square root of 16 times 3 is 48 plus 9. So that'll be the square root of 57. Ooh, this is ugly. Square root of 57. Cool. The magnitude of v, well, I mean, we got a 0, so 0. So that's nice. And then times 5, or plus 5 squared, which is just equal to 5. The distance between them, u minus v. Let me actually do that in a different color. Distance between them, u minus v. That is the same thing as negative 4 -2, yeah. And so the distance between u minus v, which is be the square root of 3 times -4 squared plus -2 squared, all under a square root, and that will be equal to square root of 16 times 3. We've done this a lot of times. 48 plus 4, which would be 52. So the square root of 52. Wow, that was so simple. The third one, it will be now not 3 points, three coordinate system, and we have 2 points, u and v. And so we are told that the inner product space between them is equal to what I underlined here. So we can just go ahead and just plug them in. So u v is equal to 1 times 2 plus 2 times 1 times 5 plus 1 times 2, and that is simply equal to 2 plus 10 plus 2, which is 14. Whoa, that was easy. Magnitude of u, square root of 1 squared plus 1 squared plus 1 squared, and take the square root. And so you're left with the square root of 1 plus 2. Yeah, 2 plus 1, which is equal to square root of 4, which is 2. For our magnitude of v, this would be 2 squared plus 2 times 5 squared plus 2 squared again. So many 2's. This is equal to the square root of 4 plus 2 times 25 plus 4. So it'll be the square root of 8 plus 50, which is the square root of 58. And then our distance between them, I don't want to do that. V minus u, which is 2 minus 1 is 1, 5 minus 1 is 4, and then 2 minus 1 is 1. And so our distance of u minus v, we know that when it comes with inner products, this is the same thing as v minus u. So this would be the square root of 1 squared plus 2 times 4 squared plus 1 squared. So all of that under square root, which would be the square root of 1 plus 8 plus 1, which is not right. 1 plus 32, because it's 32, not 23, plus 1, which would be, is it 32? Wait, 4 squared is 16 times 2 is 32. 1 is 2. And so we'll have, yeah, 32, yeah. And then it'll be 30, so it'll be the square root of 34, because 1 plus 1 is 2, plus 32 is 34. And that is it for the third example. Now let's go to the fourth one. The fourth one, whoa, we got a matrix here. And so the matrix, it's nothing too bad. We're given that the inner product space between two 2x2 matrix is given by this. And so all we just gotta do is plug and chug. So for the inner product of matrix A and B, it is simply equal to 2 times, well, it's just 0. 2 times 0 times -1. plus 3 times negative 2 plus 4 times 1 plus 2 times negative 2 times 1. And so this would be equal to, this will go to 0. It would be negative 6 plus 4 minus 4. Oh, sweet. So we're just left with negative 6. The magnitude of A, it is the square root of itself. So it'll be 2 times negative 1 squared plus 3 squared plus 4 squared plus 2 times negative 2 squared. And so that would just be all under square root, which would be square root of 2 plus 9 plus 16 plus 2 squared is 4, 8. And so that would be 2 plus 9 is 11. 11 plus 16 is 27 plus 8. It is square root of 35. Now for the magnitude of matrix B. The same thing applies. We got a 0. Cool. Plus negative 2 squared plus 1 squared plus 2 times 1 squared. So all that under square root. And that would just be equal to the square root of 4 plus 1 plus 2. Which would be 1 plus 2 is 3 plus 4 is 7. So this would be the square root of 7. And then lastly, the distance, so A minus B. That's just simple matrix subtraction. So A minus B is equal to negative 1. We got 3 minus 2, which is 5. 4 minus 1 is 3, and then negative 2 minus 1 is negative 3. Cool beans. And so now the distance between matrix A and B minus B, that is equal to the square root of 2 times negative 1 squared plus 5 squared plus 3 squared plus 2 times negative 3 squared. All of that under square root, and you get the square root of 2 plus 25 plus 9 plus 9 times 18 square rooted. And so that'll be 1129 square root of 54. And yeah, that's pretty much it. If I did my math right, this should be the answers. But yeah, that's pretty much it for this example and the lesson of inner product spaces. We are now gonna go into the last part of inner product spaces, and so that will be very interesting. But yeah, I'll see you guys in the lecture video.